Welcome to our channel. Today, we're diving into the fascinating world of physics to explore 5 amazing physical effects and phenomena that will blow your mind. We'll be journeying from the smallest scales imaginable with quantum entanglement all the way to the vastness of space where the Doppler effect governs how we observe distant galaxies. Fasten your seatbelts, it's going to be a wild ride. Okay, imagine 2 particles, right? Not just any particles, but the tiniest packets of light we call photons. These photons are fascinating because they exhibit behaviors that defy our everyday understanding of the world. Let's say, photons, those tiny packets of light, they are the fundamental particles of light, and they travel at the speed of light, which is the fastest speed in the universe. But there's something even more intriguing about them. Now these photons are linked. Not in a they're friends on Facebook kind of way, but in a deep, fundamental way that even Einstein called spooky action at a distance. This phenomenon is known as quantum entanglement, and it's one of the most mysterious aspects of quantum mechanics. You see, when you measure the state of one entangled photon, like its spin, you instantly know the state of the other photon, even if they're light years apart. This instantaneous connection seems to violate the principle that nothing can travel faster than the speed of light. It's as if they're communicating faster than the speed of light, which, as far as we know, is impossible. This has puzzled scientists for decades and continues to be a topic of intense research and debate. This isn't just theoretical, folks. We've done experiments, and entanglement is real. Scientists have repeatedly observed this phenomenon in the lab, confirming that entangled particles do indeed behave in this extraordinary way. It's messing with our understanding of reality and has huge implications for things like quantum computing. Quantum computers leverage the principles of quantum mechanics to process information in ways that classical computers cannot. Think about it. Computers that use the strangeness of the quantum world to perform calculations at speeds we can barely comprehend. These machines could revolutionize fields like cryptography, materials science, and artificial intelligence. It's like having a computer that can be in multiple states at once. Unlike classical bits, which are either 0 or 1, quantum bits or qubits can be both 0 and 1 simultaneously, thanks to a property called superposition. But here's the thing about quantum entanglement: we don't fully understand it. Despite all the experiments and observations, the underlying mechanisms remain elusive. How can these particles be so connected? What is the nature of this invisible link that binds them together across vast distances? What does it tell us about the true nature of space and time? Could it be that our understanding of these fundamental concepts is incomplete or even flawed? These are questions that keep physicists up at night, and for good reason. The answers could reshape our understanding of the universe and lead to new technologies that we can only dream of today. Let's talk about electricity, but not the kind that's powering your phone right now. I'm talking about superconductivity, a state where electrical resistance completely vanishes. Imagine a world with no energy loss in power lines, super efficient computers, and levitating trains. So how does it work? Well, at extremely low temperatures, some materials exhibit a bizarre behavior. Electrons, those tiny particles zipping around atoms, start pairing up. These Cooper pairs move through the material without any resistance whatsoever. It's like they're gliding on an ice rink with zero friction. Superconductivity has the potential to revolutionize our world. Imagine lossless power grids, making renewable energy sources far more viable. Think about medical imaging devices that can see inside the human body with incredible detail. And let's not forget about those levitating trains, zooming across countries at breakneck speeds. But there's a catch. Right now we need to keep these materials incredibly cold for superconductivity to work. Scientists are working hard to find materials that exhibit superconductivity at higher temperatures. And the race is on. You know that sound an ambulance makes as it races towards you, that high-pitched wail that drops in pitch as it passes by? That's the Doppler effect in action, and it's not just about sound. This phenomenon, first described by Christian Doppler in 1842, is a cornerstone of wave theory. It applies to light waves too. Imagine a star moving towards Earth. As it approaches, the light waves it emits get compressed. This compression shifts the light towards the blue end of the spectrum, a phenomenon we call blue shift. This is crucial for astronomers studying the universe. Conversely, if a star is moving away from us, its light waves stretch out, shifting towards the red end of the spectrum. This is known as redshift. Astronomers use the Doppler effect to measure the speed and direction of celestial objects. By analyzing these shifts, they can determine whether an object is moving towards or away from us. It's how we discovered that the universe is expanding. Edwin Hubble observed that distant galaxies are moving away from us, and the farther they are, the faster they're receding. By observing the redshift of distant galaxies, we learned that they're moving away from us, providing evidence for the Big Bang theory. And the farther away they are, the faster they're receding. This relationship is known as Hubble's law, and it has profound implications for our understanding of the cosmos. But the Doppler effect isn't just for astronomers, it's a versatile principle used in various fields. It's used in radar guns to catch speeding drivers, helping to enforce traffic laws and keep our roads safe. In the medical field, Doppler ultrasound is a critical tool for tracking blood flow, allowing doctors to diagnose and monitor various conditions. And even in weather forecasting, Doppler radar is used to predict storms, track their movement, and issue warnings to protect lives and property. It's a fundamental principle that has countless applications in our technological world. From understanding the universe to improving our daily lives, the Doppler effect is a powerful tool that continues to shape our understanding of the world around us. Let's shine some light on a fascinating phenomenon, the photoelectric effect. It's the key to understanding how solar panels work, and it earned Albert Einstein the Nobel Prize in Physics in 1921. Here's the gist. When light shines on certain materials, it can knock electrons loose, creating a flow of electricity. But here's the weird part. The energy of the ejected electrons doesn't depend on the intensity of the light, but on its frequency. Think about it. You'd expect a brighter light to knock out electrons with more energy, right? But that's not what happens. It's as if each individual particle of light, called a photon, carries a specific amount of energy related to its frequency. Einstein's explanation of the photoelectric effect revolutionized our understanding of light. It showed that light can behave both as a wave and as a stream of particles, a concept known as wave-particle duality. This discovery paved the way for quantum mechanics and our modern understanding of the universe. Hold on to your hats, folks, because things are about to get really weird. We're diving into the strange and fascinating world of quantum mechanics, where the rules of the everyday world don't always apply. We're talking about the Casimir effect, a phenomenon that proves that empty space isn't actually empty at all. This effect is named after the Dutch physicist Hendrik Casimir, who first predicted it in 1948. Imagine two metal plates placed very close together in a vacuum. These plates are just a few nanometers apart, which is a distance so small that it's hard to even imagine. You'd think there's nothing between them, right? Just empty space, devoid of any matter or energy. Well, according to quantum mechanics, even a vacuum is teeming with virtual particles that pop in and out of existence. These particles are incredibly short-lived, appearing and disappearing in a fraction of a second. These virtual particles create a kind of pressure on the plates. It's as if the vacuum itself is alive with activity, constantly fluctuating and exerting forces. But here's the kicker. The pressure is slightly stronger on the outside of the plates than on the inside. This difference in pressure is due to the fact that there are more virtual particles outside the plates than between them. This difference in pressure, however small, creates a force that pushes the plates together. This force is known as the Casimir force, and it's a direct consequence of the quantum nature of the vacuum. The Casimir effect has been experimentally confirmed, and it has profound implications for our understanding of the universe. Scientists have measured this force in laboratory settings, providing solid evidence for the existence of vacuum energy. It suggests that empty space is not a void, but a seething cauldron of quantum fluctuations with its own energy known as vacuum energy. This energy is a fundamental aspect of the universe, influencing everything from the behavior of particles to the expansion of space itself. This vacuum energy could be the key to solving some of the biggest mysteries in cosmology, such as the accelerating expansion of the universe. The discovery of dark energy, which is thought to drive this acceleration, may be closely related to the vacuum energy predicted by the Casimir effect. It's a reminder that the universe is far stranger and more wonderful than we could have ever imagined. The more we learn about the quantum world, the more we realize how much there is still to discover. So stay curious and keep exploring, because the universe is full of surprises waiting to be uncovered. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more amazing content. Remember, the universe is full of wonders waiting to be discovered, So keep asking questions, keep exploring, and never stop learning. See you next time.